Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about instantaneous rates of change.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, y equals 1 over x plus 2, and we want to find the equation of the secant line between the 2 points, negative 1, comma 1, and negative 1/2, comma 2/3, as well as the tangent line at our leftmost point, negative 1, comma 1. We're going to sketch both of these graphs. Well, first let's go find the secant line. Now the secant line involves, well, we already have the point, so we got to find the slope, right? So let's go secant here. And basically it's just the equation between these 2 points. Excuse me, because they were given to us. So our slope is equal to our y2, 2/3 minus our y1, which is 1 over a negative 1/2, x2 minus x1, a negative 1. This comes out to be a negative 1/3 over a 1/2, which hopefully you're pretty good at doing, as a negative 2/3. And again, that's our slope value. Well, to find the equation of line, it's y equals mx plus b. So we have y equals a negative 2/3, our slope, x plus b. And we can pick any point here to find the b value. I think the first point's easier. 1 in for y equals a negative 2/3, and x is a negative 1 plus a b. Solving for that, simplify this, and b comes out to be a 1/3. So our equation of the secant line combining the two is a y equals a negative 2/3 x plus a 1/3. And there's our secant line. Now let's go find the tangent line. This one's more difficult. Okay? Because we're going to use our definition of a derivative here for that. And the first thing I want to do is I want to find the definition, or find the derivative of our function using the definition of the derivative. Now, I'm flipped over here. Okay. So, with that being said, I'm going to say we want to find f prime of x here is equal to the limit as h approaches 0, okay, of our function right here. Now, oh wait, no, I'm good. Make sure I had it written right here. All right, of our function, just keep my notes there. 1 over, instead of an x, I have an x plus h plus 2. Subtracted by our f of x, which is 1 over an x plus 2, all over our h value. Okay. Now with that, I'll rewrite it over here so it's a little easier. One of the common techniques here with this is we want to find a common denominator, so we're going to multiply these two together and then bring this numerator up here and this one up there. So we have an x plus 2 up here. We're going to be subtracting that by this denominator, which is an x plus h plus 2, all over multiplying these two together. We have an x plus h plus 2 times an x plus 2, and all of that is over h. Now, let's go distribute this minus sign up here, and things are going to cancel. We have the limit as h approaches 0. We have an x plus 2, distribute that over. We have minus x minus h minus 2. All over this big old denominator. Now watch this, actually. The whole denominator right here, we have the x plus h plus 2 and x plus 2 here. And we're dividing by that h, by everything, we actually can just toss it here, they're the same thing. Now let's look what cancels. The numerator here, x cancels, and this x cancels, or negative x, and 2, and negative 2. We can keep this gravy train going. This h here and this h cancels, leaving us with a negative 1. That's right there. So this limit here, as h approaches 0, is equal to a negative 1 over this whole denominator. X plus h plus 2, and x plus 2 here. At this point, we can take the limit. Taking the limit here, we can plug h, or 0 in for h, and we have a negative 1 over, well, can't really add a 0, so we have an x plus 2 and an x plus 2. And this simplifies to be a negative 1 over, multiplying that out, x squared plus a 4x plus a 4. And again, that's our f prime of x. So, making sure my notes are all good now. I have the right value here, x prime of x, which I do. We're on the right track. So with that, we have our f prime of x. We need to find it at our leftmost value. So we only care about this x value here of the first point, negative 1. So let's go find what f prime of negative 1 is. Well, using our equation here, negative 1 over negative 1 squared plus 4 times the negative 1 plus a 4. Simplify that out. We have a negative 1 over, well, negative 1 squared is a 1, and then we have, well, minus 4 plus 4. The 4's cancel here, and we're left with just, well, a negative 1 when it's all said and done. And so our slope value right here for our equation line is just a negative 1, right? That's the instantaneous rate of change for the tangent line at our negative 1, 1. Well, we have to find the b value just like we did before. So we have y equals our negative 1, our m value times x plus b. There we go. Well, our y value has to be from the first point, which is a positive 1, equals a negative 1, right, it's a negative. Our x value here at the first point is a negative 1 plus b. The negative times the negative is a positive, so we have 1 equals 1 plus b, and b equals, well, 0. So our b value is 0, m value is 1, our negative 1, so we can write the equation of the tangent line as y equals just a negative x there, don't have the plus b. And so we have our secant line, which is y equals negative 2/3 x plus 1/3, and our tangent line is y equals negative x. Now we can sketch that or see that here on our graph. Notice that the first equation, the secant line, is through the interval of negative 1, 1, and negative 1/2 and 2/3. While the second line, the tangent line, is only there at our negative 1, 1 value, and it's a tangent line at that point. So again, our final answer, the secant line is y equals negative 2/3 x plus 1/3, and our tangent line is equal to y equals a negative x. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.